the desert regions of Central Asia. A continental climate with high temperatures in summer and cold winters. But these stretches of land are characterized above all by dryness. The low rainfall is barely sufficient for sparse vegetation to grow on the sandy clay soils. Humans are only able to live where there is water, such as here along the Amu Darya River, where irrigated agriculture has been practiced for centuries, using the snowmelts from the Pamir Mountains. One example is the Khwarezm region in northwest Uzbekistan, an enormous oasis spanning more than 6,000 square kilometers. Khwarezm has a history and culture dating back 2,700 years. Two-thirds of the population here rely on agriculture for their living. As everywhere in Uzbekistan, an important agricultural product in Khwarezm is cotton. An annual rainfall of less than 100 millimeters, combined with high evapotranspiration, means that farming is only possible through intensive irrigation. During Soviet times, immense irrigation systems were laid out, channeling the water a great distance to the expanding agricultural fields. Increased water scarcity and inefficient irrigation methods are creating challenging problems for agricultural production and endangering the livelihood of more than 3 million people along the lower Amu Darya river basin. "4,000 kilometers away, at the University of Bonn, the Center for Development Research, ZEF, has established a comprehensive research program. Since 2001, this project has been supported by the German Federal Ministry for Education and Research, the government of Uzbekistan, and UNESCO. Around 70 international scientists work together with Uzbek partners to improve the land and water use in Khwarezm. The major objectives of this project are to develop concepts and innovations for sustainable and efficient use of land and water, to involve scientists of different disciplines, but also farmers, irrigation institutions and policymakers, and to train future scientists and decision makers in and for the region, as well as building capacity by establishing research and educational institutions.
We've been asked by BMBF to do this. We agreed on a longer-term project in which we would have a phase of analyzing the problems, a phase of experimenting with solutions, and then a phase in which the solutions would be embedded in policy recommendations. In the end, the actual implementation of these recommendations will be something to be done by those people in the region. And the philosophy of ZEF was that a new generation of young scientists would probably have to be created in order to eventually make these changes happen.
The problems in Khwarezm date back to, among other things, an inefficient use of the available water resources. Water is, above all, used for the irrigation and cultivation of cotton, but also for increasing amounts of wheat and even rice. All the water necessary for farming is taken from the Amu Darya River, one of the two tributaries of the Aral Sea. In Khwarezm alone, the network of irrigation channels totals 16,000 kilometers in length. Operating and maintaining this infrastructure, parts of which are now in very poor condition, involves a lot of work and is very expensive. Only a third of the water taken from the Amu Darya reaches the crops on the fields due to percolation, evaporation and inefficient management. Since the mid-1960s, the Amu Darya's inflow into the Aral Sea has been severely reduced. During some years, it does not reach the estuary at all, meaning that the water level in the Aral Sea continues to drop. In 2006, the sea's water volume was only 10% of its size in the 1960s, with severe ecological and economic consequences for the population and a number of industries. Also, in agriculture along the Amu Darya River, decades of inefficient water use for irrigation have led to various problems. Above all, land degradation due to salinization of soil and water causes many difficulties for farmers. Excessive irrigation leads to higher groundwater levels due to capillary rise and a subsequent evaporation of the rising groundwater. The soil salts dissolved in the groundwater end up on the soil surface. The farmers try to wash the salts out of their fields by frequent flooding. However, this requires even higher amounts of precious water. Also, the drainage system shows severe deficits, so the salts often are insufficiently washed out, leading to further soil degradation. The State University of Urgench, the district capital of Хорезm. It is the project's partner university. Around 8,000 students and 500 staff study and work here in 10 faculties.
There are only a few projects like this one. Most projects have only one focus, either research or education or practical application. The fact that our project is organized in an interdisciplinary way gives it a particular standing. For example, it integrates mature scientific knowledge into undergraduate and advanced education. Therefore, research findings flow directly into the education process. It is a unique project and a prototype for future scientific education and research.
As an indication of its long-term commitment, the Center for Development Research has renovated one of the university buildings, together with its project partner UNESCO, and provided it with equipment for research and education. The building combines traditional architectural elements with modern laboratory and office facilities. From here, the project's activities are coordinated and implemented. Cotton has a particular importance in this context. It is cultivated as a monoculture on almost half of the agricultural area. Even today, the state regulates the allocation of water and fertilizers to a great extent. It also stipulates yield quantities and purchase prices. Cotton is an important export product, offering job and income security for a large part of the population. But its intensive cultivation contributes also to the current problems. One solution would be to reduce the cultivated area under cotton. But this is only possible if the cotton's value increases. In this way, the revenues of the farmers and the state can be sustained. The project's economists have therefore examined the cotton value chain. Up to now, about 90% of cotton is exported as raw cotton. The scientists were able to show that it would be possible to increase its value significantly if more cotton was processed in Uzbekistan, up to and including different end products for consumers. For the Хорезm region alone, export revenue could be doubled to a sum of $165 million, and additional jobs could be created. The agricultural areas, which are no longer used for cotton production, could be cultivated with more compliant crops, such as maize, sunflowers or indigo. In addition, crop yields can be increased by adopting more appropriate management practices in agriculture. The project's agronomists examine how this can be done by using conservation agriculture practices. For this, the soil is tilled as little as possible, constantly covered with crop residues, and a suitable crop rotation is applied. Furthermore, different crops are grown as intercropping. For example, maize together with mung or soya beans. The research findings are promising because the alternative cultivation methods are both economically profitable and environmentally friendly. By implementing conservation agriculture practices, farmers save fuel costs and reduce working time. At the same time, they raise their crop yields by more efficient irrigation and improved soil properties. Over the past years, highly salinized cropland areas have been withdrawn from cropping in Khorasan. This leads to economic losses, while the reclamation of these areas, via leaching, demands large inputs of irrigation water. The project therefore examines how these degraded areas can be alternatively used in an economically efficient and ecologically cautious way. For this purpose, the scientists have extensively tested a variety of salt-tolerant tree species and demonstrated that unproductive cropland patches can be transformed into forest areas with multiple uses. Establishing a tree plantation required less than a quarter of the irrigation amount that is necessary for the cultivation of other crops, such as cotton. After 2 years, the trees efficiently utilized the shallow groundwater, thus requiring no irrigation during the following decade. The studies show numerous advantages of afforestation for both farmers and the environment. The trees protect against wind erosion and replenish organic substances in the impoverished soil. They can also improve the livelihood of the rural population by providing fruits, protein-rich leaf feed, as well as firewood, and in the long run, timber for construction. Depending on the species, 1 hectare of 5-year-old trees can meet the annual energy demand of up to 90 people in Uzbekistan. Moreover, trees and forests sequester considerable amounts of carbon, thus mitigating global warming.
Harvesting these tree plantations for fuel wood, fodder and fruits does not contradict the idea of carbon sequestration, because the bulk of the woody biomass remains intact, and the payments for carbon sequestration can become an additional incentive for the land users to invest in afforestation of the degraded land.
Social scientists investigate how the livelihoods of the rural population have changed during the transition from a centrally planned to a free market economy. By way of example, the government has transferred water management and channel maintenance to the farmers. Organized in so-called water users associations, the farmers were suddenly confronted with complex organizational and water allocation tasks that they were able to fulfill only partially. The scientists are now trying to overcome these difficulties together with members of a water users association and the local council. They want to establish, for instance, a well-functioning water users association. Members of this collective are included in the decision-making process and annual planning. Budgets are generated, and all activities are planned, implemented, and evaluated together.
What is the total budget is half a million.
But an efficient way of managing the available water resources is not only being studied at the organizational level. Technological innovations are also being developed. The project has, for example, improved the existing system for leveling fields prior to irrigation. During leveling, a rotating laser deployed at the edge of the field enables detecting even small unevenness of the croplands. Via the tractor's hydraulic system, the height of the scraper is then automatically adjusted with centimeter accuracy. In this way, a very even ground surface is created. During the subsequent flooding of the fields, more than a quarter of the water volume usually required can be saved. Moreover, germination, growth and the uniformity of crops are significantly improved, leading to lower weed infestation and higher yields.
Is it possible for
An important aspect of the scientists' work forms their close cooperation with farmers and water users associations, as well as with irrigation authorities and policymakers. Thus, they carry out research within an everyday environment, exchange expertise and experiences, and learn from each other. The innovations developed through research are examined jointly and adjusted accordingly, so that they are accepted by all stakeholders involved. This approach is termed "Follow the Innovation." The research findings of the different disciplines are collected in a central database. It helps the scientists in their interdisciplinary work, but is available to the public as well. A geographical information system facilitates analysis and evaluation of these datasets. Detailed maps can be produced, visualizing information about soils, groundwater, crops and natural vegetation, as well as economic and social indicators. In addition, different models are being developed, such as those together with the German Aerospace Center. Using satellite data, the water consumption of individual fields can be monitored, crop yields can be predicted, and management strategies for sustainable land and water use can be developed. Furthermore, areas with water problems in the Khwarezm region can be identified. The developed model can estimate actual evapotranspiration at 2-week intervals. With this information, the water management authorities can allocate the water to match crop water demands, and therefore increase the overall efficiency of water use. The project processes the research findings and passes these over to the Uzbek authorities. They check whether they can be implemented beyond Khwarezm in other parts of the country.
Кроме этого, учеными этого проекта, на примере Khwarezmской области.
The project scientists have developed recommendations to further improve soil quality and productivity in Khwarezm. These recommendations are used by water specialists, not only in Khwarezm, but also in other regions of Uzbekistan.
The overall aim of the project has not only been the development of science-based solutions for local problems. From the beginning, institutional capacity building and the education of up-and-coming young scientists have been a focus. In the meantime, the university in Urgench has developed into an academic center with an international network, and numerous scientists from the region have been educated within the framework of the project.
Human capacity building is maybe then also one of the most outstanding results of this project, even up to now, even if the project has not been completed. Up to now we started with 50 PhD students, and about 22, 23 of them have already completed. More than master studies, 100 master studies have been started and completed, an uncountable number of bachelor studies. But in addition to the scientific education, we have also helped in educating laboratory and field staff.
Furthermore, several of the people trained in the project have combined efforts to establish a non-governmental organization called CRAS. Together with the University of Urgench, they will make sure that research and education can continue in a similar way, even after the project has been completed. With its innovative research findings, and successful capacity building program, the ZEF UNESCO project has made a significant contribution to sustainable development of land and water use in Khwarezm. A growing population and a projected increase in water scarcity mean that further efforts are necessary to ensure that, also in the future, people can use the water of the Amudarya River to practice irrigated agriculture in the arid regions of Central Asia.